So in the first of these, we looked at scaling in time. In this second one, we'll look at what happens if we get a scaling in amplitude. So this may seem a fairly straightforward example, but it's worth just remembering what might happen if we take a signal, f of t for example, and we place it through a linear system that gives some sort of scale to our signal. So this would suggest that we take a square pulse, and maybe the output will have some form of amplitude shift given by this lambda here. So what's going to happen? Well, if we take look at it in the spectrum, we'll see that we would expect from a square wave to have a sync with our regular pulses. If we assume that we have our period t and our pulse width tau, we'll have a maximum amplitude of t on tau. So we're assuming that our amplitude, which may, we'll call it 1 here, is going to be 1 times lambda, our scaling factor here. Quite simply, we're just going to get a scale in amplitude. So we will have exactly the same spectrum, but now we'll just get lambda tau on t. So it's important to know some of these relationships, because a lot of the time we'll just do very simple transforms, but actually by knowing some of the shifts we can remove some of those and deal with them outside of the integral and make our integrals much more simple. So we should also look at odd and even functions, particularly if we're going to take a product of two signals. What are we actually going to get in our signal? So if we take two odd signals together, we'll end up with something that's even. If we take an even and an odd, we'll end up with an odd, and two evens will give us an even. So we should remember these when we look at what our signals actually end up at. And so just at this point in the session, what I would like to do is to give you a triangular pulse. So this is a little bit different. In the earlier example, we looked at a sawtooth pulse, that sort of triangular pulse. Here we have both sides. And so just as a hint, we can see that our period is still t, except this time we're going to need to find an integral across a rising edge and an integral across a falling edge. We saw last time that if this was from 1 to 1, then we would have 1 minus t. We're going to have to shift that because here we're going from minus t on 2 to plus t on 2. So you're going to have to think about what this means for describing both this rising edge and this falling edge of the pulse before you can do the integral. So I'll leave you with that example, and we'll come back and give a solution to that later on.